Greetings from Earth Lab. Today we are back with a very important topic. Electricity and phases. Electricity powers our world, from the lights in our homes to the machines in factories. But have you ever wondered what makes electricity flow smoothly and efficiently? The answer lies in something called phases. Today, we'll dive into what phases are, why they matter, how they're used, and why increasing phases could be beneficial but isn't always practical. Let's get started. What are phases? Electricity is delivered in waves, and these waves can come in different configurations known as phases. Think of them as synchronized teams pushing energy along. A single-phase system has one wave of current, moving in a rhythmic pattern. A two-phase system has two waves, offset by 90 degrees, like two people rowing a boat at slightly different times. A three-phase system has three waves, each offset by 120 degrees, creating a seamless flow of energy. These configurations determine how efficiently electricity is transmitted and used. Why changing phases is important. Why does the number of phases matter? To understand this, imagine pushing a swing. With one push, the swing starts and stops moving. This represents single-phase electricity. It gets the job done but isn't the smoothest. Now imagine you and two friends push the swing at perfectly timed intervals. That's three-phase electricity. It provides constant and balanced energy. This balance is crucial for powering heavy machinery and ensuring efficient energy delivery. Changing the number of phases improves the consistency and reliability of power, which is especially important in industrial and commercial applications. What phases are in use today? The phases we use today depend on the application. Single-phase electricity, this is the most common system for residential use. It's simple, affordable, and ideal for powering small appliances, lighting, and household electronics. However, it's not as efficient for high-power devices. Two-phase electricity, while it was once popular in workshops and small industries, two-phase systems have become largely obsolete. They've been replaced by three-phase systems, which offer better performance and cost efficiency. Three-phase electricity, this is the gold standard for powering factories, commercial buildings, and large-scale operations. It delivers consistent and powerful energy, making it ideal for running motors, pumps, and other heavy machinery. Three-phase systems also support higher power loads with thinner wires compared to single-phase systems, saving material costs while improving efficiency. Why increasing the phases is good but not practical? If three phases work so well, why not add more? Increasing the number of phases has several advantages. It reduces energy loss during transmission. It lowers the current required per wire, minimizing heat and improving efficiency. It provides even more stability in power delivery, which can be crucial for certain high-precision applications. However, there are significant downsides. Higher phase systems are complex and expensive to implement. They require specialized equipment, more conductors, and careful synchronization, making them impractical for widespread use. That's why higher phase systems are limited to specific uses, such as high-voltage power transmission or scientific experiments. For most applications, three-phase systems strike the perfect balance between efficiency, cost, and practicality. The future of phases. As we move toward renewable energy and smarter grids, the role of three-phase electricity becomes even more important. Solar farms, wind turbines, and electric vehicle chargers often rely on three-phase systems to handle large power loads efficiently. Scene, a solar farm connected to a grid and EV charging stations. The future may explore advanced phase systems for niche applications, but for now, three-phase systems remain the backbone of modern electricity. The balance of phases in electricity. Electricity and its phases are a testament to how we've adapted technology to meet our needs. Single-phase systems power our homes, three-phase systems keep industries running, and higher-phase systems push the boundaries of innovation. While adding more phases can improve efficiency, practicality often limits us to three. Next time you switch on a light or see a factory in action, remember it's all thanks to the clever engineering behind electricity and its phases. Thanks for watching. If you found this video helpful, hit the like button, subscribe, and share your thoughts below. Let's keep exploring more fascinating topics together.